Hello everybody, this is a Lenovo Thinkbook 15 G2 ITL Core i7 motherboard. As you can see, it is faulty, not turning on. Now to power this, we have two USB inputs and we have a little power button here. So I'm going to plug into the USB-C inputs and see what is happening. So as you can see, I've connected my USB-C power adapter to the first of my USB-C ports. I'm going to try pressing the power button. So the power button is up here. Where is it? There is a little power button. Press it. Okay, I heard something. Okay, I'm not sure if it's coming out in camera, but there's a red light that flashes on for a second and then it switches off again. And nothing is happening on the board. There's no signs of life. So it's definitely picking up on the button being pressed, but it's not coming on. So what I'm going to do is I'm going to scan in this motherboard. I'm going to take it to the screen and we're going to start troubleshooting.
So this is what the motherboard looks like when I scan it to the screen. I have tried putting the power adapter into both USB-C ports and it's doing the same thing. When I press the power button, a little red light flashes on for a second and nothing else happens. It's like it's trying to start and immediately shutting down. So let's get a look at the input section. So we have our two USB-C ports here. Now I don't see a track directly from this to any IC on either side of the board. However, what I do see is a combination of two sets of fuses and MOSFETs. So this looks to me like what we normally see after a PD controller. Now, one thing that's slightly different about this week's motherboard is you can see there appears to be just one IC that appears to be the PD controller for both of our USB-C ports. See this IC here? So we've an output going to the fuse and going to the two MOSFETs here. And we've an output here going to this fuse and going to these two MOSFETs here. If we take a look at the datasheet for that, you can see this is in fact a TPS 65994AD dual port USB Type-C and PD controller with integrated power switches. So what does this do? The TPS 65994AD performs cable detection according to the USB Type-C specification. It also communicates on the CC wire using the USB PD protocol. When cable detection and USB PD negotiation are complete, the TPS 65994AD enables the appropriate power path. It also means that both of our USB-Cs are coming through the one IC. So if that one IC is blown, we don't have any redundancy. So what should we expect to find in terms of voltage readings? Well, if I look up the original power adapter, you can see the original power adapter is voltage of 20 volts and it can deliver current of up to 3.25 amps. So what I would expect is when we plug in our USB-C power adapter initially, we will read 5 volts. And after it's negotiated with this PD controller, we should read 20 volts the whole way along here when we plug into this USB-C. And when we plug into this USB-C, we should read 20 volts the whole way along this path here. And that's the power that's delivered to our system. So the first thing I want to try is see on the output of these MOSFETs, are we getting the correct 20 volts when we plug in our USB-C power adapter? So with my first USB port plugged in here, we're going to zoom in on this section right here and have a quick look at how this works. So if our PD controller IC is working and it successfully negotiates with our USB-C adapter, we should be reading 20 volts here. So that 20 volts should come on then to this fuse and through this fuse and onto the MOSFET. Now this MOSFET is an AON 7506 N-channel MOSFET. If we look at the pinouts on that, we see that we have 3 source pins here, a gate pin and then 4 drain pins on either side. Because this is an N-channel MOSFET, we should be expecting to see high voltage on the gate pin, maybe something like 24 volts, in order for this to be switched on and to permit our 20 volts through from here to our drain pins. If it gets through that, it comes on to a second MOSFET. This is also a 30 volt N-channel MOSFET. Let's mark the pinouts here again. So we have 4 drain pins on this side, 3 source pins here and a gate pin. Again, it's an N-channel MOSFET, so if our gate pin is high, that will switch the MOSFET on and permit our 20 volts through to the source pins, which is then our main 20 volt power rail. So with our USB-C power adapter still connected, let's take some measurements. First of all, we introduce our multimeter in volts DC in a 20 volt range, place our black probe to ground, and then with our red probe take a measurement after the second MOSFET, so at the source pins here, and what I find is it measures 5.10 volts. And just in case there was something wrong with those two MOSFETs, I took a measurement right back at the PD controller and confirmed that it's measuring 5.10 volts there also. So it seems that our PD controller is not successfully negotiating with our adapter and giving us the 20 volts expected. I decided to try plugging my USB-C adapter into the second USB-C port. Now, the second USB-C input follows this path. It's a parallel path similar to the path we've already traced out. So what I wanted to do was measure again at the fuse for the second USB-C port, just where it's connected to the output from the PD controller. And when I measured there, I found that it also measured 5.10 volts. So it seems once again that we have a problem with our PD controller IC. I took a closer look at this IC with the microscope, but I couldn't see any signs of damage. I also checked out the two USB-C ports and confirmed that they were fixed firmly to the motherboard and there was no signs of damage with those either. So is there anything else that we can do to see if this laptop is functioning and if it's only the PD controller that's at fault here? Well, as I mentioned earlier, I'm expecting to find 20 volts here when this PD controller is negotiating properly with my USB-C power adapter. So how about we try and inject 20 volts into this rail here from my DC power supply. So where should we inject our 20 volts DC? Well, if I zoom out a small bit, you can see that our 20 volt power rail should be coming along here and up onto this jumper, and I think that is a good place to inject our 20 volts DC, and then we can try and power this laptop on. Now, before injecting 20 volts DC with my own DC power supply, I thought it would be a good idea to make sure that that 20 volt power rail is not shorted. So I disconnected my USB-C power adapter, I introduced my multimeter in diode mode, I placed my red probe to ground this time and placed my black probe to that jumper connection, and I read 0.595. So there's no short on that 20 volt power rail. So having confirmed that our 20 volt power rail is not shorted, I introduced my DC power supply. I connected my black wire to ground and I connected my red wire to that jumper connection, and I set it to 20 volts. So as you can see, I've connected the ground wire from my DC power supply to that screw hole, and I've connected my red wire into my jumper. I have turned on the power supply, I've set it to 20 volts and it's now drawing 7 milliamps. So let's try powering it on. Well, our power switch is down here, so I'm going to press it. Okay, so immediately my power supply has started drawing over an amp and back down to over 700 milliamps. Okay, so right now we're not seeing anything on the display. Okay, the light has come on there, but I'm still not seeing anything. And would you believe it? So it is actually working. Okay, so if I inject power at this jumper here, the laptop power is on. So it appears that everything from this point on is actually working, and the only issue is with this PD controller IC here. So we had one of these that failed last week, and now another one this week. Do I need to just buy a load of the most common PD controllers, because it seems like we're going to be facing this same issue a lot? So that's my video for this week. It looks like I'm going to need to buy up a lot of these PD controllers to keep them in stock. If anybody knows like a good kit that gives you maybe the top 20 of the most common PD controllers that I can just buy in a box, put it in the comments below, please, because I think it might be useful. It's really expensive when you buy these individually, because you have to pay the shipping, and we have to pay customs on these coming into Ireland as well. So if there was one kit out there that has the most common PD controllers, please post it down below and I'll just buy it. That's all I got for this week, guys. Please like and subscribe, and I'll have something new for you next week.